All right, let's take a look at covalent bonding, which is a quite a bit more complex and more interesting than ionic bonding, which is relatively simple. So in covalent bonding, instead of transferring an electron from one element to another, two elements will share electrons. So we'll just say electrons shared. And so naturally we want to know when this occurs. And so this occurs when we have multiple nonmetals. Right, so one or more nonmetals. Again, drawing our little staircase. It's when we have multiple of these atoms combining with themselves. So for example, if we have hydrogen with its one dot, oxygen with its two dots short of an octet, and then another hydrogen, they will not combine ionically, right? So H plus O2 minus and an H plus type of situation, that's not what's going to occur here because both of those elements are non-metals. So what instead occurs is we have the hydrogen with its one dot each or one valence electron each, oxygen with its two valence electrons short of each, short of the octet. And what they do is they share these electrons. Note again that hydrogen only wants two valence electrons or a duet. To have that filled outer shell. So there's many ways we can depict this. So we can draw it something like this, which we won't draw it like this too much, but let's just go ahead and identify it. So we have the dots above and below oxygen. We call these lone pairs because they're by themselves and they belong to the oxygen only. These dots in between the two elements, right, in between the oxygens and the oxygen and the hydrogens are what we call a bonding pair. And so then we want to think about how many valence electrons does each one have. And so the magic of covalent bonding is that it allows us to double count the bonding pair. So for example, when we're looking at this hydrogen, we count both of these hydrogens on either side as belonging to the hydrogen. So hydrogen has satisfied its desires and has that filled duet. Then when we think about oxygen, we double count those oxygens that are in the bonding pairs and count the lone electrons. And if you think about that pink circle that I just drew, there's 8 electrons there. So it has its filled octet. Right, so by bonding, we're allowed to double count our electrons. And so then both of the elements are happy because they have both a filled valence shell. So we won't draw our structures like this. We're going to draw them slightly different. This is what are called Lewis structures, or just another form of Lewis structures, really. And so instead of drawing the dots between our elements, we're just going to draw a line. And then we're just going to leave the lone pair on oxygen as it was. So these lines here, what they represent are chemical bonds or covalent bonds. And they represent each 2 dots or 2 electrons, right? So each line is equal to 2 electrons, right? And then you can tell hydrogen now is happy, it has its 2 electrons, oxygen is happy, it has its 8 valence electrons. So let's take a look at what are known as diatomic compounds. So this is just 2 atoms combined with themselves. So for example, we have chlorine. And in chlorine, right, each one of these chlorines is 1 short of a filled octet. And so what it's going to do is share 1 electron each, right? And so the way we can draw this is chlorine, they're each going to donate 1 electron to the shared electrons to form this covalent bond. And then they've each got 6 lone electrons or 3 lone pairs. And now they both have a filled octet. Similarly, oxygen, if we think about oxygen, it can also bond with itself. Oxygen has 6 valence electrons. So if we think about oxygen, each oxygen is 2 short. So they're going to share 2 electrons each, or 4 total. And the way that this is going to look is as a double bond, right? So we're going to have oxygen, oxygen, and then they're going to share 4 electrons. That way they each have an octet, and each one is happy. In general, right, we're going to draw our bonds as lines, not as dots. And again, if you think about counting the valence electrons for each oxygen, the bonds get double counted. So for this oxygen on the left, we've got 2, we've got 4, we've got 5, 6 from that bond, and then 7, 8 from that bond. So it has that filled octet. And then this oxygen over here, 2, 4, and then double count these, 5, 6, 7, 8. They both have 8 valence electrons. Another example is nitrogen. If we think about nitrogen, it has 5 valence electrons, so that's 3 short of 8. And so it's going to share, each one is going to share 3 electrons for 6 total. And if we think about 2 electrons per bond, that's a triple bond. So there's going to be 1, 2, 3. And then again, if we think about counting the valence electrons for this nitrogen on the left, 2 right there, 4, 5, 6, 7, 8, right? Remember, each bond counts as 2. And then over here, we've got 2 from this lone pair, 2 from this bond, that's 4, another 2, that's 6, and then this one, that's 8, right? So they both have 8 valence electrons. So atoms will form single, double, and triple bonds with one another as needed to get that filled octet. In general, these bonds have different properties. So, you know, your single, your double, and triple bond, as we've seen, and as you probably would be able to predict, the triple bond is going to be stronger than the double bond, which is going to be stronger than the single bond. Right? There's 3 bonds that's stronger than 1. Interestingly enough, it's not 3 times stronger, but it is stronger. And then the other property that they have is bond length, right? How long are these bonds? And as you might be able to predict, a single bond is actually going to be longer than a triple bond because the 2 atoms aren't held as tightly together, right? So you can think about that, you know, as the bonds, as the kind of springs or glue or, you know, lines that are keeping them together. And if you have 3, they're going to be held tighter together, right? So the triple bond is also the shortest bond, whereas the single bond is the longest. Again, where this is just an introduction to chemistry, we're not going to go in super in depth. We're just going to lay the groundwork for you to succeed when you take that 101, 102 course, where you'll learn a lot more in depth.